Okay guys, let's go ahead and get started. So please take out your 3.1 video notes and we will do it right now. What are we doing today? Write this on top of your paper. I will identify functions. So I will identify functions. All right, so we talked about functions a little bit last year, but let's definitely do that again this year because we're going more in depth, okay? So what is a function exactly? A function is when there is exactly one input, remember that's an x, for every output, and your output is the same thing as saying y. So inputs are always x's, outputs are always y's, okay? In other words, now I know this sounds very mathematical, so really what you just have to know is this. In other words, to be a function, your x's do not repeat. That's basically the rule. The x's do not repeat. To be a function, your x's do not repeat. All right, so let's try the first couple of examples. Determine whether this relation is a function, and then please make sure you explain why. So a lot of times on your test, we're gonna write explain. So if you don't do that, you are gonna lose points, okay? So we have our inputs x's, 8, 4, 2, 4, 8. And then our outputs. Remember, you have one input for every output. Do you see how this input of x goes to the output -4, and the same input of 8 goes into the same or a different output of 4? Okay, so this is not a function because, or no, because really you have two of the same inputs. Or you can say because your x's repeat. Or you could say because there is not one input for every output. It doesn't matter what you write as your reason why, but you have to write something that makes sense. So really, this is so easy. All you have to do is say, okay, to see if it's a function, all you have to do is take a look at your x's, and your x's are your inputs. Do any of these repeat? 0, 2, 4, 6, 8. No, they did not repeat. So this is yes, it's a function because your x's did not repeat. Okay, let's take a look at this one. This one's a tricky one. So just look at your x's. Oh, I have a -1 and a +1. Are those the same numbers? Did they repeat? No. -1 and +1, even though they're the same digit, they're two completely different numbers. So yes, this is still a function because the x's did not repeat. And then finally, let's take a look at this one. Just look at your x's. Who cares about your y's? 1 and 1. Oh, they did repeat. But hold on, this is a trick question. I probably shouldn't have crossed it out. Do you see how that's a 5 right there? And this one was a 5 right here. So that's a trick question. It's actually the same point. If it's the same point, then yes, this one is still a function because the x's did not repeat. I mean, yes, they did repeat, but they go to the same number. Like this one, they repeated, but they went to two different numbers. If it's going to the same number, then yes, it's still a function. They're just trying to trick you, okay? All right, so that's one way that you can see if something's a function. Another way is if you have a picture of a graph, then you have to do something called the vertical line test. So the vertical line test is basically you taking a vertical line and then you deciding yes or no if it's a function. So let me quickly show you what that would look like, okay? So determine whether the graph represents a function, explain why. What I'm gonna do is I'm gonna draw a bunch of vertical lines. As I'm drawing vertical lines here, my picture should only go through my vertical line once, and it does, right? This dot only hits it once. This dot hits it here. This dot hits it here. This dot hits it here. So then my answer would be yes, it's a function because it passes the vertical line test. Okay. What about this one? If I draw a bunch of different vertical lines, like here, do you see how it touches here and here? It touches it in two spots, or even here, it touches it here and here. So this is not a function because it does not pass the vertical line test. Or you can say it's not a function because your x is repeated. Your x is repeated here and here. Okay, for this one, if you draw a bunch of vertical lines, does it pass the vertical line test? Yes, because it passes vertical line test. here's a tricky one. Okay. You would think, yeah, so far it passes, so far it passes. This one right here, you might think, oh, it touches here and here, it does not pass. It actually does pass because you see how this is an open circle? That means that this point was not included in this line right here. So that does pass. Like right here, you might think, no, it doesn't pass because of these 2 points, but no, it does. This is an open circle, so it does actually pass because this point is not included, whereas this closed circle, it is included. So yes, because it passes the vertical line test. Okay. Now let's talk about different types of graphs. You have a discrete graph and a continuous graph. A discrete graph is a graph that only plots certain numbers. Like it just plots specific numbers. Whereas a continuous graph, it plots all the numbers. Like all the numbers, how about we were in between? Okay. And then finally, before we get to these examples, let's talk about domain and range. The domain is all possible values of your input, which is your x. And then your range is all possible values of your output, which is your y. So basically, domain is always x, range is always y. Okay. So let's try these examples. Find the domain and range. So my domain, D, my range, R. All right, this is tricky, okay? My domain are the x's. Well, here's my x-axis. Okay, so I'm basically looking at everything going horizontal, okay? So do you see how on my x-axis, where do these dots touch? They touch at -3, -1, 1, and 3. That's where it touches on my x-axis. So my domain would be in parentheses, -3, -1, 1, and 3. This is also called a discrete graph because it only plots certain numbers. Just this one, just this one, just this one, just that one. So this is called discrete. Okay, my range is y. So y is your y-axis. So where do these dots touch this y-axis? It touches at, let's say, the 0, the 2. 2 of them touch at 2, but that's okay. 0, 2, and 3. So my range is 0, 2, and 3. Okay, I know that was kind of weird. So you try this one by yourself. Okay, first of all, is this discrete or continuous? Hopefully you realize that it's discrete because it only plots certain points, just certain numbers. All right, so go ahead and pause the video. Just try it yourself. If you get it wrong, that's okay. This is really brand new, okay? We'll talk about it a lot tomorrow too. So try the domain, try the range. Okay, so go for it. Okay, so hopefully you tried something. Okay, so domain, remember domain is the x. So the x-axis is right here. Where do these dots touch the x-axis? At 1, at 2, and at 3. So my domain is 1, 2, and 3. Has to be in parentheses. Has to go in order from smallest to largest. Okay, now my range is y. Y is the y-axis. Where do these dots touch the y-axis? At 2, at 3, at 4, and at 5. So 2, 3, 4, 5. That would be my range. Okay, this one. Now, do you see how these two are actually continuous graphs? They're continuous because it's not just certain dots. These dots are connected by lines, which means they continue throughout the entire graph. Okay, so let's find the domain and range. So my domain and my range. Sorry, you're kind of writing small here. Okay, my domain. Domain is the x. X is right here. Where do these dots touch the x? It starts from 0 and it goes all the way to 2400. So the way that we write domain and range for continuous graphs is, well, domain is x, so put x in the center here. Okay, then you're going to draw these two inequalities where they're always going towards the right. Okay, and it looks like my domain starts at 0 and it ends at 2400. So that's my domain, from 0 all the way to 2400 and everything in between. That's why you have these inequalities. right? If you just listed off numbers, it would be just 1, just 2, just 3, nothing in between that. All right, let's look at the range. The range is this one right here. So for my range is just the y's. So y in the center, write your inequalities going towards the right. Okay, from smallest to biggest. So where's the lowest it goes? Right here. Okay, and where's the highest it goes? Right here. And let's see what they're counting. Oh, no, that's not the highest. Silly rabbit. This is the highest. Okay, so it looks like they're counting by 2, 22, 24, 26, 28, yeah, so they're counting by 2s. So the lowest is 22, the highest is 30, 32, 34, 36. Okay, so I would say the range goes from 22 all the way to 36 and everything in between. So basically for the range, find the lowest point, find the highest point, and that's your range from this number to this number. Okay, last one. So this is also a continuous graph because all of these are continuing on. Like it has all the dots in between as well. So here's my domain, here's my range. Okay, so your domain is the x's. So where does it hit? It hits here, 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 here. Do you see how there are arrows on either side? That means it keeps on going forever, and it keeps on going forever here. So if it keeps on going forever, then you think to yourself, okay, my domain is, well, if it keeps on going to the left and keeps on going to the right, well, think of it this way. If it's continuous, always put x in the center, and then always put y in the center. Okay, domain keeps on going to the left, 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 left. So it basically goes to negative infinity. If it keeps on going to the right, 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 and it keeps on going on, it goes to positive infinity. When you have infinity and infinity on all sides, both sides, you write all real numbers. Every real number is a domain. Now my range, so my range would be this, the y-axis, right? How low and how high does it go? How low does it go? It goes to 0. How high does it go? Well, so it starts at 0. That's how low it goes. How high it goes? It keeps on going up, 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 up. So it keeps on going to infinity. Whenever you have infinity on one side, just cancel it out. So your final answer is y is greater than or equal to 0. All right? Y is greater than or equal to 0. Okay. Backside of your video notes. You try. Please pause the video and try it yourself. Go. Okay, hopefully you did these 4. Let's see how you did. Domain, range. All right, my domain, the x's. How far to the left, how far to the right? Since it's continuous, I'm going to start my domain and range by writing it like this. Not just separate numbers, but it's an inequality. It keeps on going to the left because there's an arrow. It keeps on going to the right because an arrow. So infinity and infinity. Remember how we said infinity on all sides? All real numbers. Range, how low does it go? Well, there's an arrow going down, 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 so negative infinity. How high does it go? Up, 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 up. The arrow says, positive infinity. So again, infinity, infinity, all real numbers. This time it's all real numbers. All right, for this one, this is a discrete graph because there's just dot, 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 dots. So we're not drawing the inequalities. We're writing, just listing off numbers. So my domain is the x-axis. Where does it hit the x-axis? At -2, -1, 0, 1, 2, 3. So -2, -1, 0, 1, 2, 3. Okay, my range. Where does it hit the y-axis? Start from the lowest one. Hits at -8. Then what? -5. Then -2. Then 1. Then 4, because I'm counting my 2's here. And then 7. So that would be my range. All right. For this one, domain and range. Oh, look, it's continuous. It's not just a dot, dot, dot. So if it's continuous, I have my inequalities set it up like this. Okay, domain. How far to the, that's the x-axis, right? How far to the left did I go? 0. How far to the right did I go? What am I counting by? I'm counting by 0.4, I think. So 3.6. So I started from 0, and I went to 3.6. I know I stopped because of these dots right here. Okay, range, low and high. So how low did I go? I'm counting by hundreds, so 50. How high did I go? 500, so 50 to 500. Okay, last one for my domain and range. It looks like I have separated things, but that's okay. All right, so for this one, it looks like I have, well, here's my inequality. So how it looks like I went from negative infinity, right, all the way to -2. But wait, it doesn't actually touch the -2 because it's an open circle. So it's not less than or equal to, it's just less than. Okay, then I went from -2 all the way to +1, and then I stopped. And it looks like I went from +1 all the way to, infinity. Okay, and remember, if there's an open circle on +1, you don't need this line on the bottom. Okay, I need more room to finish this off. Remember, if I have infinities on either sides, I just cancel this one out and cancel this one out. So my final range is x is less than -2, -2 to x to 1, and then x is greater than 1. This is my entire domain. Okay, I know, it's complicated. Now let's do the range. Range is up and down. Well, wait, where does it just touch the range? -3, and then what? 0, and then what? 3. So those would be my ranges. -3, because if it's just the y, right, where does it touch? The -3, then the 0, and then the 3. That's where it touches. All right. Moving on, independent and dependent variable. What you need to know between them is this. The independent variable is always going to be the x. The dependent variable is always the y. This is vocab that you have to memorize, okay? This is how I think of it. Whenever you have an equation, what number always changes? You can plug in anything you want to for the x, right? So this is my independent variable because it's independent. You're like an independent woman, an independent man. You can do whatever you want to do. Well, so you can be whatever number you want to be, so it's independent. But the y depends on what you plug in for x, right? You don't know what you plug in for x. So this answer, the y, depends on what number you put in here. So y is dependent, x is independent. That's how I remember it. All right, so the function blank represents the monthly cost y in dollars for a group of X members joining the fitness club. So identify the independent and the dependent variable. So here's the independent, here's the dependent. Remember, independent is X, dependent is Y. So independent is X. What is X? Oh, X members. So it's members. Dependent is Y. Y is what? Dollars. So it would just be dollars. Okay. Letter B, your group has enough money for up to 6 members to join the fitness club. Find the domain and range. So here's the domain, here's the range. Remember, the domain is X, the range is Y. Okay, so for my domain, it's like what we did up here. Do I write inequalities for the domain or do I write list of numbers? Well, what am I plugging in? X is members. Can I have like a decimal of members? No, I have a whole number of members. So my members, I have up to 6 would be 0, 1, 2, 3, 4, 5, 6 members, right? I can only have up to 6 members. So what's my range? What would be the answer if I plugged in 0, 1, 2, 3, 4, 5, 6 in here? I don't know. So let's figure that out. So let's plug in 0. 7 times 0 plus 35. My first answer would be 35. Okay, so my first one is I can have 35, what is that, dollars. Okay, now let's plug in 1. If I plug in 1, I have 7 times 1 plus 35. So that's $42. So then that would be 42. So do you see what I'm doing? I'm plugging in each of these numbers and getting the answer. That will take me a lot of time. Here's a trick. Okay, I'm going to clear my calculator, by the way. All right, if you go to the y equals and type in this equation, 7x plus 35, and then go to your table, here are all of your answers. With 0 members, I have 35. With 1 member, I have 42. With 2 members, I have 49. With 3 members, 56. With 4 members, 63. Keep on going until you get to 6 members, and those are all my answers. So you could do it that way too. Okay, moving on. Determine whether the statement uses the word function in a way that is mathematically correct. So basically, is this situation a function? And then explain, yes or no. All right, a function pairs each teacher with 30 students. So if I have a situation where I have 1 teacher with 30 students, is that a function? I hope you're saying no. And then it says why. Okay, so think, if you have 1 teacher and every 1 teacher has 1 student, 1 student, 1 student, 1 student, all the way up to 30 students total, right? This is your x, This is your y. Do you see how your x's are changing for every single thing? Like you have one x, that one teacher, for all of these different students, for Johnny, for Sarah, for Tommy, for, whatever their names are. So this would be no. And then because you can basically explain it in words or write that as your explanation. Okay, second situation. The cost of mailing the package is a function of the weight of the package. So the cost compared with the weight. Is anything being repeated here? No, right? So if nothing's being repeated, then yes, it's a function. Why? Well, think of it this way. If you have something that's 1 pound, 2 pounds, 3 pounds, let's say everything is, $2 per pound. 1 pound is $2. 2 pounds is $4. 3 pounds is $6. Do you see how all of these numbers are not repeating? So then that would be a function. Okay. Last but not least, find the domain and range. Okay, so for this one, domain and range. So what you do is you put it in your calculator, go to the y equals. Okay, this is how I type in absolute value because that's the absolute value symbol. Hit second and then 0. So this catalog button. And then do you see how ABS stands for absolute value? So second 0, which is catalog, and then enter ABS. So type in X. Arrow out of there, -3. Hit graph. Look at the picture, and then you can figure out the domain and range. Okay, they're all connected, so I know that it's continuous, so I know my domain and range has this. All right, domain, how far to the left, how far to the right? It goes on forever and ever and ever, because look, if I hit zoom out and then enter, do you see how I still see the picture zoomed out? It keeps on going to the left and to the right, so infinity, infinity, what is it really? All real numbers. My range, though, let me zoom back in. My range, well, from how low to how high? How low? It looks like it goes to -3. I can honestly look at my table, too. Do you see how the lowest number it goes for the y's is -3? Yeah, it touches -3 here. So it goes from -3 all the way up, so to infinity. If I have infinity on one side, cross it out. So y is greater than or equal to -3. Okay. Last one. So go to the y equals. This time it's negative and then second catalog ABS. Negative x and then arrow out +1. Go look at your picture. Okay, so domain, range. It's continuous again, so make sure you have your inequalities. Then think to yourself, domain, how far to the left, how far to the right? It keeps on going, keeps on going. Infinities on both sides, which means you have all real numbers. My range here, how low does it go? Well, it keeps on going down, so that's negative infinity. But how high does it go? It looks like it only goes to 1. Let's double check. Yep, it only goes up to 1. 1's the biggest number. So if you have infinity on one side, cancel it out. You have y is less than or equal to 1. And that would be your range. Okay, I know this was a difficult lesson. If you have any questions, please make sure you ask your teacher tomorrow, okay? Good night.